Okay, so I guess it's no secret that the data center industry is under significant pressure to increase its capacity. I mean, we've got the digital world there already, and then along comes AI to sort of drive a coach and horses through that, and even more capacity needed. But obviously, at the same time, the industry is under quite a lot of pressure from the sustainability lobby. So, just your thoughts, I suppose, as to those sort of two, if not contradictory, at least not complementary, should we say, tensions.
Yeah, it's a very topic that's very close to me. I not too long ago wrote a white paper for ASHRAE, which is the industry association that I belong to, where I call it a paradox. And that is, we want a healthy indoor environment, but at the same time, we want to be mindful of the energy we're using and be sustainable. And these two factors tend to want to fight each other. So how do you bridge that gap? How do you make spaces healthy and efficient? Data centers are a prime example of such. Lots of need for heating and cooling, and more cooling than heating because of all the heat from the machines. And as well as the fact that with large volumes of space, typically or traditionally, they will bring in a lot of outdoor air. And the reason that that's done is outdoor air has always been kind of the balance against indoor air quality. So it's almost going back to the way things were many years ago. If you didn't like the way your inside felt, you opened the window. So mechanically, we open the window quite a bit. But as you can imagine, when you have a window open, it's kind of hard to keep the temperature right. So that's where the paradox comes in of trying to be sustainable, but then again, having a healthy and efficient environment. But the good news is there are solutions. There are ways to use technology that we have available to us that can balance the two, that can allow you to have that environment that you need without wasting energy. And I think that's something that's very good that we've developed.
Yeah, and in terms of the challenges that you sort of alluded to there inside the data center, optimizing performance, protecting the hardware, and with the sustainability angle, minimizing the HVAC energy use. I mean, they're just a few of them, but they're quite important aspects that need addressing. Is that right?
Yeah, exactly. I mean, there's a lot of different aspects in a data center that are critical. One is, of course, you have to have temperature maintained correctly because you can't have the machines becoming too hot. Another thing that's very important in the data center is the control of static electricity. When you get times a year, especially when it's less humid, you may get static charges, and static charge could hurt sensitive electronic equipment. So your control of humidity or other means to control static is very important. The other factor is filtration. Dust, dirt, things of that nature that could collect tend to want to attract to those machines because of the static attraction. The machine has a charge, the particle wants to find it and plates out against it, almost like it does to computer screens and other things that have a charge. And on computer servers, there's a need to move air through them. And if those vents where those fans are trying to move that air become clogged up with dirt or dust over time, well, of course, they can't move the air effectively. The machine overheats, the machine could have a fatal failure. So it's important not to have an overly dusty environment, which becomes more challenging when you're bringing outdoor air because outdoor air can be laden with dirt and dust and things that you wouldn't want inside. Anybody that's ever lived through a wildfire experience, like we had here in the northeast of the U.S. Last year, would well know when outdoor air is poor, you almost have nowhere to hide. So it's so critical in what you're doing to your indoor air to try to maintain a balanced environment.
Okay, and in terms of addressing the air situation, the air quality in the data center, I believe that bipolar ionization is a potential or an actual solution to this. So can you for those of us that don't understand, can you just give us the basics as to what it is, and then we can perhaps explore, well, what it is, what it does, and then explore what AtmosAir's, interest in it is as well.
Sure. Bipolar ionization, air ionization, is actually a very simple concept that is a part of the natural ecosystem of the planet. All air is ionized. But in areas where, let's say, it's cleaner and more pristine, far away from population, the ion levels are much higher. But as we get down into areas that are populated and then we get into our indoor spaces, the pollution that man's made and emissions have kind of depleted that natural source of ionization. So what a bipolar ion system does at a very basic level is to restore the indoor air to what you'd find in that clean, natural environment. The ionization process has the ability to clean air in many different ways that are very advantageous because it uses very little energy in the process. There are many air cleaning forms that can clean air well, like high efficiency filters and other techniques like carbon that can absorb odors and gases. But they use a lot of energy. They restrict airflow. They make it harder to heat or cool a space. When you do that, naturally use energy. And of course, you're not being a friend to sustainability. So one of the nice things about the ionization technology is that it's a very good part of a sustainable solution because it doesn't use much energy by itself or by nature of how it works.
And AtmosAir yourselves, you've actually developed some HVAC tubes, if I understand correctly, and these emit bipolar, both positive and negative ions, and that's, if you like, taking the if you like, the theory or how it works into an actual practical solution to target the airborne contaminants. Is that right?
First, I have to give credit where credit's due. The original technology was developed by a collaboration between Albert Einstein and a person by the name of Conrad Habish way back in the early 1900s. The device that we produce, the tube, is actually a specific type of ionization. It's called dielectric barrier discharge. That's really the most widely used form of bipolar ionization. Europe has been using it for many, many years. There's studies going back to the 1960s and 70s. We've been, using it widely throughout the globe since 2004 when we formed our company. What the bipolar tubes do is they cause particles to agglomerate. They become bigger and they become heavier. First, they lose their charge, so they don't want to cling to things, which is very important in a data center. But those big, heavy particles are now easier to filter out with a less efficient filter. But also, some that never get to the filter settle to the ground very rapidly, and they don't stick to equipment. So that's extremely important. Another factor is that it strips away gases, odors, fumes, things of that nature. When you're in a place like a data center, you're bringing in lots of equipment all the time. You have furnishings, you have other things. You can get a buildup of these gases, and some of these gases can be corrosive over time. When you have an ionization process that's basically oxidizing these gaseous contaminants, reducing them to carbon dioxide and water vapor, you have less of a concentration, less of a concern. Another benefit of the bipolar ionization process may be less so in a data center because data centers generally don't have great amounts of people, more so in occupied spaces, is that they have the ability to kill the bacteria and viruses and germs and molds, organisms that can, obviously make people sick. And that's a very meaningful benefit to the technology. But one of the great benefits to a data center or any place that needs to bring in those volumes of outside air is with prevailing codes. When you can clean air effectively, you don't need to bring in as much outside air to satisfy the mechanical code, and therefore you have less of that air that needs to be heated or cooled or certainly dehumidified in a lot of cases to be comfortable and efficient inside of a space. So that less load uses less energy. And of course, that energy translates into both dollars and sustainability goals. So that's where that technology, the BPI technology, can be extremely beneficial.
So if I understood correctly, you're saying the tubes there are added to the existing HVAC system, and they then, as you say, reduce the requirement for the outside air. And then in sustainability terms, that means you're lowering energy use, reducing greenhouse gases. Is that the sort of the simple equation, if you like?
Exactly. It's beautifully simplistic, I always find. Um, and one of the nice things about the bipolar ion technology is to implement it doesn't require you re-engineering your mechanical system or doing a great deal of mechanical re-engineering in order to accommodate it. The tubes simply go in the airflow that's going to be supplied into the space. They infuse it with ions. They kind of make that indoor environment the same environment that you might find at the top of the mountain or far away from man-made population. And those increased ion levels, those are the things that are doing all the work here that reduce the need for that outdoor air.
And maybe if we can just sort of flip it the other way, if you can just explain or remind us in terms of the importance of filtering the outside air. In terms of, if you don't, what are the problems that contaminated air can cause? I'm thinking, I don't know, reducing the cooling effectiveness, which I guess then leads to higher operating temperatures, or you've got to ramp up the cool. Just characterize the, if you like, the downside of allowing unfiltered air or less good quality air into a data center facility.
Sure. I mean, probably the biggest issue would be with particles. Fine particles will oftentimes get through even an efficient filter. Also, filters can sometimes be a little bit suspect in that the filter may be very good, but if it's not fitted very well into the mechanical system, it allows for gaps around it. And if it has a gap, air always wants to find the path of least resistance. And so it allows air that's completely unfiltered to go by. But when you get a lot of fine particulate in a space that has sensitive computing equipment, that particulate will build up. It becomes visible dust. It can clog up the air inlets and outlets of the servers and the computer equipment. The computer equipment can overheat, and it could have a fatal failure. So it's important in a data center, any place that's using equipment like that, that the air is well filtered. Many times, data center may have grades of filtration that are even more so than you'd find in an occupied indoor space because of just that fact. They have to keep the equipment free of dust, free of dirt, so it operates correctly. And then the outside air is kind of part and parcel of that problem. Outside air is laden with pollen and dust and all kinds of fine particulates that challenge those filters. The more that you're bringing in to kind of counterbalance the air quality, the more difficult the job you're giving to the filter. So if you can use a technology like bipolar ionization that cleans up the space effectively, neutralizes static, which makes the dust and dirt not want to cling to the equipment, reduce that dust and dirt, and reduce that outside air need, now you're taking away a lot of the challenge. You have filters that can operate more effectively, and many times you can actually use a less efficient filter or a lower restrictive filter that allows better airflow, which again reduces your operating costs. So the technology can really aid in a strategy to kind of reduce your costs, but at the same time not compromise the indoor environment.
Okay, so maybe you can perhaps summarize the situation. I mean, a lot of data center owners, operators, they've got plenty on their plate, shall we say, as we've alluded to with AI, sustainability, and lots of sort of high level topics. And maybe contamination control, I won't say it's overlooked, but it's not necessarily as high up the agenda as it perhaps should be. Just any advice you can give to folks in terms of implementing, developing and implementing a sort of comprehensive contamination control strategy. Clearly, what we've talked about today is part of that, but just more generally, your thoughts as to how people can ensure that they're, addressing this, this situation as optimally as they can.
Certainly, as again, AI becomes more prevalent, there's going to be more of a demand for conditioning. That's going to mean that the owners of operators of these data centers will have to bring in more tonnage, more cooling capacity. As they're adding tonnage, again, if you stick with the traditional methods, the need for outside air is going to grow. That's going to make, again, that cooling demand, increased tonnage, increased outside air, mean more and more and more energy use, less and less sustainability. When you can look at strategies like the dielectric barrier discharge ionization, integrated with your HVAC upgrades and also with your outside air, what can happen is you might not need to bring in as much tonnage. Now, when you bring in less tonnage, number one, for the operator, that's a pretty big savings. Tonnage is rather expensive. So when you bring in less HVAC capacity, you save cost on your first cost. But of course, running smaller air conditioning equipment that's using less outside air uses much less energy. And so you can see a significant savings. Another thing that a lot of data center operators face, especially in the colder climates, is humidity. And that is, many times they may be bringing humidity into the space to reduce static shock when it's very dry out and there's not natural humidity levels. But humidification can be a very difficult thing to deal with because it needs to be maintained very regularly. If humidifiers aren't clean, they grow mold, they grow bacteria, they can present a lot of environmental problems. But they also are expensive to operate. They require a lot of energy to produce that humidity to kind of enter into the space and to really get the humidity level to where it needs to be, that kind of, in and around that 40 to 50% relative humidity. Bipolar ionization, because it is positive and negative, neutralizes static. So when you can use that kind of technology, which is much less to operate, and not have the cost or kind of the concern of humidity, that's a big benefit to the space. So again, the neutralizing of the static, when you combine it with the ability to reduce fine particulate, and also the outside air and the extra tonnage that you might need to accommodate that extra load that will happen because of the new AI requirements, really kind of adds up to something that would allow a facility to be more efficient. At the same time, have a good, balanced, and healthy indoor environment, and and be more sustainable as well.
And maybe just a final query from me in terms of a typical engagement with a customer. I mean, is this, whether it's your specific technology or contamination control more generally, is the data center industry, shall we say, underperforming in this area? It's not doing all that it needs to do, or are you pleasantly surprised when you go into most data centers that they understand the idea and are working towards it, but just need a bit of help? Or are a lot of data centers, if not unaware, certainly not far down the road? To just, I suppose, characterize where the industry's at when it comes to contamination control and I guess your technology specifically.
Mm-hmm. It's all about education. Many data center operators and certainly many engineers that might be looking at those upgrades that are needed or those mechanical systems to accommodate the increased demand may not be aware of this technology. A lot of engineers tend to do things the way they've always done them. It's a relatively easy position to just kind of follow tradition. But when I find that when we talk to people and they become educated on this technology and how it could benefit them, and really how little it is to implement it, they become very open to the concept because it just makes all kinds of sense. The cost isn't something that's prohibitive, but the benefits far outweigh the cost. And in most every case, when you're implementing this technology in a data center and really any indoor space, you're going to find that your investment is paid back, and then afterwards you're going to enjoy savings and better sustainability.
Okay, it's been lovely to chat, Tony, and thanks for sharing your expertise in this area and educating both myself and our listeners. I really appreciate your time today. Thank you very much.
Thank you, Philip. It was my pleasure, and thank you for having me.
Thanks again.